Okay, sorry for being late. Something soft just now. I hope all of you are doing well. I think we have, I think 2, 3 weeks no class already. So actually, it's the time for you to finish the report. Uh, okay, regarding first of all, about the project report. Project report one, I believe most of you already done that. Okay, finally, I will give the deadline for the submission for that report is in this Friday lah. This Friday 3:30 p.m. So you can check through Kalam. I already put the link. I mean put the place to drop your to submit your report lah. So you need to submit the report by group. I believe most of you already formed the group already. For those who just new, so there's no way other than to catch up for the report and submit on the Friday before 3:30 p.m. It's all same for all sections, so make sure you submit it before the 3:30 p.m. this Friday. Okay. Okay. So I think I'm not sure whether you still remember or not. For the several weeks before, I already what you call that? I already put the installer for the EKTS software in the Kalam. Then you can download. Let me show. Let me show. Okay, this is your Kalam. This is your Kalam screen. Uh, so I put there's the EKTS simulation software here. Then you can download lah. Okay, you can download and purposely in this version of the motor control class, uh, we are not going to do any practical practical test. I mean no practical class. Practical class to assemble or to do the wiring or magnetic control and so on of the motor control. No, we are not going to do that. We only focus on the simulation. However, if we have extra time, maybe for those who are available in Gambang, for those who are available, maybe at the end of the semester, maybe we just come to the lab only for the sightseeing only. Just come for the enjoy only. Maybe you can just simply touch here and there only. We are not going to assess you just for the sightseeing. Okay. Oh, excited But that one I think maybe but don't expect too much. Don't expect we have a very high tech of the lab. I think just the simple thing. We only the simple thing. DOL okay lah. Maybe that level only. But that one maybe 13 weeks of course lah after the raya lah. After the raya maybe on week 13, week 14, maybe before. For example, we do the test on. For example, we do the test on week 13 or week 14, but not in the class hour because we have other two section also, and I think we have same time what we call the same timetable with the section 1G, but not with the 3G. 3G maybe different time. That's why we cannot do the test in the same class hour. So maybe the sightseeing will be in class hour, but the test maybe the end of program will set it back. Okay, so uh, that's why most of the cases you're going to learn. I think maybe some of you already start to play with the EKTS or at least install already in your laptop at least lah at least. Okay, so EKTS 100% you're going to learn by yourself with your team. Because we have three, maximum in group three. So I think for simple project, you have three brothers or three sisters or mix, then you can finish it with no problem lah, and of course lah kan, expect it. Don't say that please give some negotiation for us, and no, no, no. Because we are giving you the task in group, so I expect you to learn by your teammates and to finish the lab report and record the videos. I think record the videos for the there's difference between the lab report. Okay, project report one only submit report with the rubric. Please refer the rubric once you submit the lab. We give you the lab sheet. But for the case of report, you must follow all the items stated in the rubrics in order for you to get a good marks If we just submit the exactly the same like the lab sheet, so you are going to get the same as the lab sheet only because there's the item there's the item for the full report. So please simply write your report based on the rubrics given. I think they what we call if you write it based on the rubric given, following that things, I think there's no reason for me to give the very low marks for you lah. Okay, that's the tips. One tip. Second tips one, starting from this week, you can start seriously play with the EKTS software, and you are going to do the project one. The project two. Sorry, the project two. We have 4 reports so the project 2 report is about direct online and the forward reverse. Okay, forward reverse bias. So that you need to simulate it. You need to create. I mean, you need to as the one of the what we call it, one of the item that must be submitted. It's not only report, but a part of the result. A part of the result is the video that you simulate the DOL for reverse bias and other. I think another one star data. That one for project 3 lah. I don't want you to just pick up from your old brothers from the previous semesters, take their working software. I mean working program already. So just explain. No, that's not enough. You need to from the zero. I mean from the scratch. From the white sheet, from the white plane. There's nothing until the what we call until the DI is work fine with your explanation. You have three members, so I think I expect you can finish it so easily, maybe. Okay. For those, I think there's some group haven't formed yet, so please be hurry. Okay, find your brothers. Okay. Alright. So today. Actually, you can read by yourself, but still, I want to teach you about the DOL lah. For reviews, I think you can read by yourself. Okay. Before that, any question or any dissatisfactory? Do you want me to take the attendance? I need to take the attendance maybe. The attendance I will update in the column later. Later you can simply check in your attendance lah. I will set in column. Saya buka lah sampai pukul 6 petang. Pukul 6 petang, pukul 7 malam saya open je lah. Nanti you just simply check in the attendance in the column lah. Okay. Okay, no question before I start the direct online. It's not so you can read by yourself, but okay lah. Never mind. No question lah. Can you hear me or I'm talking alone?
Yes, can hear.
I know, very boring because we don't have the physical class for this. It's actually the lab, same like low voltage electrical installation. It's very complicated for us to make it simulation. It's easy for you to understand well if you do the wiring works. Same goes with the motor controller. When it comes to the simulation one, it's totally become like this. Very boring. Okay. Alright. Okay, we start with the direct online. Direct online. Two things here. Okay. So this direct online starter DOL. The content principle of DOL motor starter, electrical schematic circuit of DOL, power circuit, control circuit, components of DOL motor starter, operation of DOL motor starter. As I mentioned before, you can just read, but allow me to read it for you. Okay, in the DOL starter, an induction motor is connected directly across its three-phase supply. Okay, because in motor control, we are playing with the three-phase induction motor. That's why induction motor is connected directly across its three-phase. This the oil starter also requires the three-phase supply. And the DOL starter applies the full line voltage to the motor terminals. Despite this direct connection, no harm is done for the motor. Okay, we are not going to directly connect the motor directly to the power supply. Of course, we have the gate, which is the DOL. Okay, motor starter contain protection device, air protection device, some cases conditional monitoring. Since the DOL starter connects the motor directly to the main supply line, so the motor draws a very high inrush current compared to the full load current of the motor. Okay, DOL starter connect the motor directly to the main supply. The motor draws a very high inrush current compared to the full load current of the motor. We have the DOL between the power supply and the motor. That's why the motor draws very high inrush current. Compare if we connect directly the power supply to the motor. Okay, the value of this large current decreases as the motor reaches its rated speed. Uh, for the startup current to very high. Okay, but the value of this large current decreases as the motor reaches its rated speed, stable speed. When we reach the rated speed, it looks like the car. When you start to accelerate at the time, very high current or we consume a lot of energy. That's why if you drive, just ada application lah. If you drive inside the pekan, okay, Gambang near to Gambang only, compared to if you speeding in the highway. If you check your gasoline, I mean the fuel level, definitely the fuel level will consume much if you just drive within your area. If you go to the highway, because while accelerating, of course, it consumes a lot of fuel. Or if for electrical also, the starting point, they consume a lot of energy at the first place. And once it's reached at the stable speed, so we don't use anymore we just maintain. That's why we are using cruising and something like that, and then we can maintain. At that time, the accelerated current or any additional current also will decrease at the time when the speed is achieved at its rated. Okay, that's why the starting is very critical lah. The starting part, the starting motor, it consume a lot of energy. That is why if you know maybe in all place, no, all school of office that use a three-phase, or in all classes also they use we call that air conditioner, three-phase. Actually it's three-phase one, all stuff. You have the switch green and red. That is the DOL switch. So that machine or that air conditioner that use that switch is actually accelerated current is very high. It consumes a lot of energy actually. That's why once they're on, they don't off. But recent air conditioner, I give you an example air conditioner because they use motor, because they use the inverter type. So the starting is quite slow if you use the inverter air conditioner to become cool it takes time. But at the time, because they quite energy saving but they don't consume much at the starter. During the starter, they don't use the DOL anymore. But if you do use DOL, they start up. During the startup, they consume a lot of energy, a lot of current. That's why recently, this kind of motor control basis of application is not, I'm not saying it's not 100% irrelevant, but in the recent technology is quite outdated but still, for the sake of academic, at least you know lah, at least you know the DOL is exist. Okay. Can you hear me well, or I'm talking alone again? Okay ke?
Okay, sir, okay.
Okay, okay, boleh faham kan? You can understand it. Alright. Uh, okay. Direct online starters are commonly used to start small motors, especially three-phase squirrel cage. Squirrel cage tu I think I show you last weeks before that motor. Ni ada tak dalam ni? Ni ada tak? Motor yang sebelum ni, motor tu, ni ada stator tu. Ni three-phase squirrel cage. Squirrel cage yang motor yang I present last several weeks tu. Nanti kau tengok lah. Okay, as I mentioned before, it use full voltage. Okay. The oil starter applies the full line voltage to the motor terminals. Okay, suitable for motor less than 5 horsepower, and below. For voltage starting method, there's advantage and disadvantages. Disadvantages. Okay. Easiest method to employ, lower equipment costs. You buy DOL like that. Most reliable, generate highest starting torque. Okay, torque. The first acceleration is quite critical. Shortest acceleration times because speed up. What is the disadvantage? Higher strain on the power system due to the high starting current. That's why this is the problem. Imagine. I know this is not relevant. Let's say you use the. It's quite relevant, but still, if you use solar, then you have the battery. You have the battery, but you have the inverter. Why inverter? Because you want to use the AC and inverter is inverting the DC signal to the AC signal. It sounds strange. For example, after the inverter, here comes the AC power. Then you use this motor. It's not relevant lah. And after that, the oil, it's weird. It's weird. But let's say we depends on the battery end. So because the high starting currents is consume a lot of energy at the first place. So if the battery, there's a limit. If it's too much current you use, battery will shut down like that. Battery is not enough power, that kind of issues. So that is the one of the disadvantages when we use the DOL. It consume spike current. Not it not used for all the time, but the spike current too totally will affect the strain, higher strain on the power system lah. Sudden spike. That one for single motor. If we use in one office, one factory, all are switched in the same time. So imagine the spike current how much. So it totally will disturb the power system. We are talking about one for example, one air conditioner with DOL, not only one unit. You imagine one big factory, all factory that use DOL air conditioner system, DOL based air conditioning system for their staff. So if they're on at the same time 7 a.m., you can see the very high spike current at the first very evening. Maybe it can disturb the power system. I mean, too much overload. It can cause that. Okay. Then can cause a temporary voltage drop to the power system. It's the same chronologically from here due to the high starting currents. So it will drop. Voltage will totally drop all of a sudden. But after that, of course, become stable. But once drop, it can disturb. It can lead to the trip, something like that because overload. Okay, overload. Breaker will problem, something like that Okay. Can cause sudden loading to the driven equipment. Sudden loading is got very high current. It's all chronological from here Okay. That's why people are now we use the smart system. Then they use sometimes there's high switching current, high power current, high MOSFET. Okay, high power MOSFET switching device instead of DOL Okay. So I think that's a solution for this. But still, the DOL is we call that legend Okay, legend. Okay, so this is the electrical schematic circuit of DOL. Okay, it consists of two. This DOL in this motor control is consisted of two circuits. One is the power circuit, and another one is the control circuits. Okay, one is the power circuits and the control circuits. Okay, the connection of this DLL and the components included in here. If we refer to these circuits, so we need some MCB 40 amps, MCB 6 amps, 7 microcontrollers, overload relay, induction motor, depends lah, 1 or 2 horsepower. As soon as less than 5 horsepower is applicable. We have the push button start, where the push button stop, PB start and PB stop, and we also have the indicators lights. Okay, so that's the components included in the DUL system. Okay, then as the operation of DUL, basically we divide it into three states or three stages. Okay, three stages. One is the initial condition. Second is the when the start button is start to be push to press, and the third one when the stop button is later press. Okay, okay. Okay, let's see. Let's go for the first stage. Boleh nampak kan? Saya nak buka full screen dia tak comel. Okay, this is the first stage. So what we have here, for the power circuit, it is connected in three phase. So it use 415 volts. Okay. But for the control circuit is connected in single phase only. It's actually 230 lah. 230 230 volts. AC recent the rated for the TMB is 230 230 volts. Okay. We start from the control circuit. Okay, start from the control circuit. So first stage, we call it as the initial condition. Okay, initial condition when the originally circuit like this. So this is this is the initial condition. Okay, when nothing is applied on the circuit, just as it is. So here, the stop push button is what you call that? Is connected like this. Okay, and the start push button is not pressed. Okay, so at this time, okay, the current is flowing like this. Okay, at this level, magnetic MC1 is not energized. Okay, so the motor is not running. What is the MC1 and where is it? So this is the MC1. So this is MC1. Okay, what is the relationship between MC1 and this one? So MC1 is here. Chronologically, MC1 is here lah. Okay, so this is the control circuit first. So before power circuit. Okay, so for the control circuit, it needs only 230 volts, but the full the power circuit need three phase. Okay, in order to completely accomplish the circuit of the DOIL, so it needs the 215 volt. Okay, at the first initial condition, the stop push button it become like this. So nothing happen. Then because we haven't this circuit is open. This circuit is open. That's why it's not connected here. So originally what will happen to here is this circuit is connected like this in this direction. There's a magnetic connector. This is normally closed. You can check the device, the components, the notes before. So this is the normally closed connections. That's why without anything, the circuit will flow in like this. So the stop light, this is the stop light will on. Okay, stop light, indicator stop light will on. While the indicator trip light, yellow and run light are off because this push button start is not pressed. Okay, is the initial condition. Okay, okay. Alright. So this is the first stage. Okay. So means uh, I'm not sure you any ID 19 here? Ada kan? Abdul Rahman, ID 19 eh? Muhammad Yusuf, also ID 19. Have you gone to Pekan? Have you attend or any class in Pekan before the COVID?
Yes.
Yes.
Okay. Uh, if you see there's a panel board aircon. I think I forgot lah which room. Sometimes they have the green red switch, something like that lah. With no aircon. Without aircon also you can see the red light it's already turned on, just like that. But when when you want to turn the aircon, then you need to turn green one, and then after that the red light will what we call will disappear and it comes the green light later lah. So that very old school, that old school panel board. We still use that in Pekan eh. Uh, we didn't replace it with the totally fully inverter. We're not smart enough. We use everything that still okay. We can simply continue use lah. No need to waste the money eh. Okay. So that's why the stop light is, even though the air conditioning is not on, it's originally the red button. I mean the red light is on because it is it explain what call it. It want to show you that is in the initial condition lah. No aircon, but the red light is turned on ah. Red light ah means there's nothing. There's nothing happen. Initial state. Okay. Then it happen. The second condition is when you press the start button. Okay. You press the green button. The green button because you feel very hot. You feel very hot and then you want to turn the aircon. So you press the green button. So this is the push button start. The green one. When you press it, beep. Okay. When you press it, this circuit start to close. Okay. Okay. The circuit start to close. So the current will flow like this lah. Betul? Right. So the current will flow like this. The moment you push it, the moment you push the button, and the circuit is closed. So the current is flowing like this. So this MC1 is energized. This MC1 is actually works as the electromagnetic coil, and this one is normally open, and this is normally closed. This is also the magnetic commutator. We have three magnetic commutator, but the function is slightly different. This one is used for normally close, normally open, normally closed, and this is the electromagnetic coil. So once the push button start is pressed, then this MC1 will be energized. Energized magnets start to pump, and because the energized and then become electromagnetic and is stick to each other. I mean the plate, the inner plate. Okay. One is stuck with the any contacts to him. Mean any contacts to him, which this brother, this normally open brother and this normally closed brother will change the direction. Means that from normally open, it will become to normally close. It will close ah. It will close. This brother from normally close will open. So it become normally open at this moment. Okay, at this moment. Okay. Then when we look for this the first MC1. I mean the normally open now become normally closed already. So this brother, when it is connected, so the current also will flow like this. Correct? Eh? Mean there's the biflow of the current. One is here, another one is here. Can you see? Do you understand what I'm trying to write here? Even it look mess. I messed it. I messed the drawing. Okay ke? Boleh ke? Boleh ikut lagi ke? Brianda. Brianda kan. Okay. Even I mess all the drawing, you can still understand? Ibrahim Adam. Ibrahim Adham. Hijau ah. Understand eh? Nizaruddin ada juga kat sini. Okey. Siapa lagi ada dalam ni? Nurul Ain. Ha. Boleh dapat lagi ke?
Ya, sir.
Boleh nampak walaupun serabut sikit.
Boleh, boleh.
Boleh kira boleh Okey. So I continue boleh I continue. So means there's another flow of current here. Okay? And then okay alright. Then I'm saying just now, the moment we push the button now, the moment we push the button of the start, the moment we push the start button, everything become like this. Okay. Then after that, after we push, we release our hand, we release our fingers. Means that this push button start will return back to normal. Macam mana return back to normal Become like this again sorry. Saya tulis balik kat sini. Okay. MC1. Then this the PB. Start. The moment we release our finger, it will open again It will reopen again. Will reopen means there will be no current flow at this way. Because the circuit is already open. Reopen it back. But the circuit can escape to this to this loop This is what we call latching circuit. Latching circuit will reach that the MC1 here, the MC1 here still can be energized. Okay? It will keep energizing. Though the push button start is already released from our fingers, but because of this latching circuit, the circuit will keep continuing flowing. Okay? When it's continue to flow, the MC1 will keep energizing. Okay? Keep energizing. Okay? So it keeps energizing. So until you said stop. No, not say stop. Until you until you press the stop button, it will stop lah. Means that everything is energized Though, okay, we already released the push button start, and then even though this part is already cut, it's already open, but because of this latching circuit, the MC1 will keep energizing. Okay? Keep energizing. Okay, so keep energizing. So once keep energizing, this, because I told you, this MC1 is related to here, it's actually here. So it starts to trigger the whole power circuit to work. That's why when it becomes contacted, ta-da! So the current will flow directly from the power supply to the motor, and the motor will start to turn until you want to stop. Okay? So at this point, less energy is used here. Because once it open, then just like that, there's no, but for the control circuits, they takes time to energize the motor control, something like that. Okay? So once, okay, this is the second condition means at the time motor already moving. Motor moving. Okay. So this is the second stage. Okay. This is the second stage. Okay. So the last stage. Okay, the last stage. Simple. Press stop button. Settle. Simple ABC. Press stop button. Where is the press button stop? This is the red one. You see the red one. Okay, the red one. In the panel board, you can see the red one. So you just press that button. When you press that button, it will open the circuit. Nampak ni? It will become like this okay. Open. When the circuit is open, everything is cut off. All of a sudden, without waiting. That's why you can hear the sound macam tu kan. Like that kan. Something like punching. Because when we stop the button, everything stops instantaneously. Because we cut it, this one also will cut. It start to return back to normal. So this brother will become again the normally open. And this brother will return back to the normally closed. So at that time, the stop light will reappear again. Okay, will reappear again. So that is the function of the DOL. Okay. Okay, this motion you need to illustrate and present it in your report by using EKTS simulation software. It's part of your task lah. Project report 2, DOL and forward reverse bias. Okay, so this is the DOL. So you need to, from the scratch until the moving, with your explanation, with your 3 members must be in that video. Make sure your face is there, and you present it, and you divide lah which part you are going to present. I leave it to you. Make sure in that video don't too long, don't get too long. If the video is very long, because you need to put one by one, you drop one by one, you drag one by one component, the MC, everything. You do time lapse lah for the drop and drop, and for the drop and drop, what we call part, you time lapse, make it fast. And then explanation, please don't make it fast. Explain it one by one lah. Okay. Alright. So that's a part of your project report 2. You already can done. You can start already your project report 2. Without submit the report 1, you can start already the second one. Very fast. Okay. Okay, that is it for the DOL. Okay, for overload trip case, because we haven't touched yet to the trip case. Okay, this trip 1. The trip 1 is connected here lah, the connection of the trip 1. Okay. So for the trip 1, so there's I think the component for that. Okay. Overload trip case. It's actually we have, because we installed already the overload. Where is the overload one? Let's see, this one. Overload the overload switch. Okay, the circuit will be tripped if the current flowing in the loads is greater than the permitted setting value for a period of time. Though we have the rated current, that we set for the motor. Once we have motor, we already set how much current is expected. But sometimes, sometimes maybe because of if the motor itself is broken, it's broken, maybe some damage. Sometimes it becomes very hot. Due to that hot, too much power is dissipated. It becomes too hot, and sometimes, or the cable inside there melting, the winding is not properly well. Sometimes it can drive you, the current will be driven more than the expected rated one, because it's broken. For example, 6 amps, it can go to 7 to 8 amps. That's why we call it as broken. It can happen, maybe trip inside the windings not properly well. I don't know why. Maybe sometimes we don't know. We don't know. Inside the motor, we don't know. Sometimes it happens to break down. So at the time, we need to replace it. So at the time, maybe the setting current, the generated, the unexpected generated current is more than the more the set one. So at the time, it will trip. Okay. The setting of value can be done by turning the set knob at the overload relay. So overload relay, this is the current set. The part for the current set. This is current set. It's very difficult. If I'm not sure we have this kind of things in the Gambang. I haven't checked yet. But in Pekan we have. In Pekan we have. Uh, you can simply set the knob. Use the screwdriver. So this the overload relay. We can set the value manually. Everything is manual. To test functionality of the overload relay to trip case, push the white test button on the OL with the test pen. Ni, this button lah. Simply use the test pen. Don't use your hand or needle. Don't do the stupid things. So we just the test pen. Put, you stop. Just to test. But don't play with that. Okay. In event of trip, the contact of the overload relay is changed from 96 to 97. Therefore, trip indicator light will turn on. Where is the 96 and 97? Don't worry. There's not something that you don't know nothing. It's actually because I said here. Allah, nampak. This is 96. This is 97. That's the only thing that we're going to say. One is this trip. It will change the direction from here to here. It becomes like that. It will connect here. Then when it is connected to the trip light, the trip light will turn on. Simple. Okay. So mean the power supply is supplied directly to the trip light only lah. Means it will not damage. It will not further damage the whole circuit. Okay. It will not further damage the whole circuit. Okay. Then the strip one. So when we set already, what should we do? I mean, we want to return it back to normal. Reactivate the circuit is very super simple. Reactivate the circuit, we must reset the OL at first. To reset the overload relay, simply press the reset button on the overload relay. Port. Same like ESCB. ESCB, you can reset back. There's reset button there. Very simple. Just push the reset button and will turn back to normal. Normal condition. As the initial state condition. Any question? Even though I write and thank you. Any question?
Okay, doktor.
Okay kan? Simple sangat kan? Tak tahu lah nak baca je.
Doctor.
Okay, Abdul Rahman. Alright?
Yeah, I have a question.
Yes, question.
After we connected to the trip, what happened after that?
After we connect to the trip.
Yeah, to the trip.
Okay, the circuit is stopped. The motor is everything stopped.
Okay.
Okay, and then if you want to maybe stop and then change the motor, change the motor, turn off the, of course lah, they turn off the MCB. So this is the mechanical work of the what you call that? For safety lah, protection, mechanical lah. And then you can change, you close the MCCB, then you change the motor and something like that. Once you replace everything okay, then you press back on the OL, the reset button, and it will turn back to normal. Then after that, you try to start again your air conditioner by pressing the green button. Working lah. Like that lah.
Okay.
Okay.
Thank you.
Okay, any question? Another question? So this is the DOL. One more thing. Okay. Right. 10 minutes. 10 minutes only. I need your 10 minutes only. Because 5:30, maybe you are preparing for the iftar already, even too early. Okay. Next is the forward reverse. Okay, forward reverse. Motor starter. Okay, principle of forward reverse starter, electrical skirt, power skirt and control skirt, component forward reverse starter, operation of forward reverse starter. So the operation can be summarized as follows. Simply interchanging any two of the three-phase power input leads to the stator windings reverse direction of rotation of the magnetic field. In other words, very simple, forward movement, let's say clockwise, the motor turn to the clockwise, you just want to turn it in the different way. So this is what we call the forward reverse starter, motor starter. Okay, we change the polarization or we change the terminals of the power, the same motor. Okay, to check over the magnetic field. it will turn the terminal, you know, because we are based on the electromagnetic. So once we change the polarity, then the movement also will change and the opposite ways. That's the meaning of that. I think the very very relevant application like washing machine lah. Oh, okay. All washing machine, not the front load. All same. The washing machine lah. You know, washing machine, they one direction stop and again they change to different direction like that lah. So that the basic. If you want to understand it, the best analogy is like we are changing the polarization of the motor rotation direction of the washing machine. That's the idea lah. Okay. The number of poles is determined by how many times a phase winding appears. In this example, each winding appears twice. So this is a two-pole stator. Okay. Example of forward reverse connection. The basic idea is for example, this one, the first terminal L1 connect to T1, L3 to T3. But when we change the direction, L1 is now connected to T3 and the L3 is now connected to T1 while the T2 is still remain the same. Only two terminals are changing here. So we interchange the L1 and L3 while L2 is maintained. So that's the basic idea of the forward reverse motor starter. Okay, there's power circuit. For the case of power circuit, for the forward reverse circuit, the difference between the D or L, there has the second magnetic contactor installed here. If for the D or L, we only have the left side end for the power circuit. But for the forward reverse, there's additional magnetic contactor. They are installed in this part. Okay. And then for the case of the control circuit part, so for the control circuit part, compare to the DOL. So DOL, if you still remember, we have the what we call that stop. We have the stop end, but here we don't have lah. We have another circuit. So this circuit is the reverse part. Okay. So this is the forward part. Okay, forward part. And there's another difference also. They install another normally closed magnetic contactor between these two part region. So like I mentioned, so this is the forward reverse forward part. Okay, forward part. And this is the reverse part. Okay. How to change the phase supply to the motor originally from D or L? Okay, just the difference, we don't have the what we call that, another magnetic contactor and for the stop end. We don't have that. So we don't have that. So we simply add another additional magnetic contactor. Okay. Second magnetic contactor is installed in this region. Okay. Okay. With the connection, okay, there's that terminal is connected like this. Okay, like this. And remember, this part is connected to here. Okay. This part is connected to here. And the third one, the R1 is connected to the R1. Okay. Okay. That's the connection. And then after that, here comes the additional another start push button start, and we have the normally open. Okay, normally open another magnetic contactor. Then we just duplicate it. We just duplicate both left and right. Okay. It start when the this start button you push. When you push, so it start to generate. I mean the current is flow here. Okay, and this is the energize. Okay, once this is also energized. Okay, latching circuit is also have here and is energized. The MC1 is energized. So once MC1 is energized here, this part is contacted, right? So once this part is contacted, so the current flow as usual. Okay, the current flow as usual. So it will go through from the power supply directly to the motor as the simple direction, which means that U1 equal to R1, R1, U1, V1, V1 equal to Y1, and V1, W1 as usual. Okay, so the MC1 is energized, so the motor will turn in the, I'm not sure, maybe in the clockwise direction. Okay, in the clockwise direction. That is the case where the MC1, okay, MC1 is energized. Okay, and then the motor will turn, for example, clockwise. So it become only clockwise here lah. Okay, clockwise. Okay. Then after you use that, like I told you, this is the mechanical, mechanical, not the washing machine. Concept is the same. I mean, we change the polarization, but the washing machine, they have the timer, they have the everything, so that everything is done automatically. But for this case, for example, we finish with the first one, and then second one, we are going through for the second one. I mean, second one, we want to but we want to it turn in a different direction. Okay, same motor use, but in a different direction. So at this case, we'll push this button. Just now, after we finish the first one, MC1, and then we close it as usual, and it stopped. Then second part, we want to energize this M2. So once we open this circuit, so it will energize MC2, and this also will the latching circuit will work. Okay, will work, and this the contact is closed. Okay, once the contact is closed, so the M2 will energize. Once M2 will energize, so everything is contacted, right? This three terminal is contacted. So one is contacted, remember, because this direction is connected into a different direction. We purposely connected the wire in the different direction. So means this, that the yellow one will remain the same because it's in the middle. But the red and the blue will change the terminal. So when we change the terminal means that now U1, where is the U1? Okay, U1 equal to B1 here. Okay, V1 and Y1 yellow is remain the same, but the W1 and R1 is now inverse. That's why this terminal, for example, this terminal and this terminal is now changed already. Okay, once it is changed, the direction also originally from clockwise maybe now turn to the anti-clockwise, like that. Okay. Okay. Okay, saya sampai sini je lah. What happen if both start forward and start activate at the same time? So okay, this is the question they ask. Okay, and then is it possible if we both start? Okay, it cannot be because there is protection here. That's why we need the protection here. This contacted magnetic contacted normally close. Okay, normally close is installed. That's the reason why we install the normally close magnetic contactor in this part. Okay. Okay, the rest spot difference between DOL and FR starter, it's okay lah. Okay tak? DOL FR starter, number of magnetic contactor, number of start button, number of start indicator light, and number of ordering circuit. Ordering circuit is same with the latching circuit. Oh, okay. Latching. Okay, dah 5.5. Alright. Okay, what is the difference? Difference between DOL and FR starter number. The number of components installed in there. Magnetic contactor, How many magnetic contactor in DOL? How many magnetic contactor? How many we have magnetic contactor in DOL? If you still remember. Wih, tidur. Bashar Abdullah.
Not sure, sir.
Not sure. Yeah, you can read at least. It's not that important actually. But I still want to ask the question. Okay. But what I want to say, the different only the numbers of component only lah. The number of magnetic contactor, number of start button, okay, start button, stop button, start indicator light, number of latching skirts. That's the difference between the DOL and the FR. Another thing, the name of the forward reverse bias we already know lah. Forward reverse bias we can interchange the direction, the movement, the rotation of the motor clockwise and anti-clockwise by changing the polarization by installing the second magnetic contactor in the circuit or the original circuit DOL. And after that we add up another numericals and number apa lah. So this is the number of components. Yang ni tak apa. I think this one you can read the back. Okay, this one you can read back. I already upload in the kalam. Okay. Trip case also is the same. Okay, you just can read. Very easy lah. For me, it's not that difficult. Okay. Okay, I think that's all. Only 1 hour. We need only 1 hour, but the rest means that now I leave it to you for the second project report. Okay, second project report. It looks pressure because you haven't submitted yet the first one. Now I'm asking you second one, but no, don't worry. Maybe I will give you another 3 weeks more. Maybe 3 weeks. 3 weeks maybe. 3 weeks before the submission because you need to learn the EKTS software again. Then you need to understand the DOL, the function of the DOL, and then you need to simulate, do the video, everything, and then you need to know the forward reverse bias also. You need to do also the video for that, and you need to drag one by one, study the EKTS. So I think 3 weeks. 3 weeks. It will take you 3 weeks to study with your team members. Okay. As usual, don't get pressure with this subject. We are not going to have next week class. We don't have next 2 week class. So we don't have. I'm asking once you submit, maybe the same week with the submission of the project report 2, then we are going to have a class to study for the next. Maybe that one star delta maybe. Okay, maybe star delta at the time. Okay. Later on, I will inform you back. Okay. Any question before I leave? Any question? This card I already upload. Any question?
No, Doctor.
No, Doctor. Tanya orang sikit. Shazril, any question? Muhammad Abdul Hamid, looks like you have question. You open the mic already.
No. Sorry, I opened my message. I don't have any question.
Okay. Okay, remember, don't forget your project 1 report. Submit on the Friday before 3:30 p.m. Okay, same with all section also. You need to submit the report. Remember, your report must follow the items in the rubric. Must contain the rubrics, the item in the rubric. Okay, don't just simply submit that lab sheet. I cannot guarantee. If you get the lower mark, don't be angry with me. Okay. So if no question, then that's all for today. Okay, I will upload this recording.
Okay.
Yes.
Sorry, it's not a question, but we are 2 in group.
Okay.
So can we add it 1 or enough 2? Or we should 3?
No. Minimum is 2, maximum is 3.
Okay.
But not 4. If 4, too many sleeping brothers. I don't want the sleeping brothers one. 2 is the minimum one. 3 is maximum.
All right.
Okay. Don't forget your project one report. Okay, Lo Fui Chi. Question. You raise your
Sir,
hand. Yes,
do
yes.
the lab sheet. We only
Okay.
want representative untuk for submissions, or we have to submit. All of the members have to submit it.
No, only one report per group. But please include your brother's name lah. I mean your team member's name lah. If you don't
Alright,
put the name,
thank you.
I consider it's only two lah. Okay.
Yeah, understood.
Only
Thank
one
you, sir.
report. Only one report per group. Any other question?
Yeah, sir. For
Yes,
the
sure.
rubric,
Yeah.
and one PDF with the report.
I write in the where? Rubric for lab report is all the same for all project report. We use the same rubric for all project report.
Okay.
I uploaded already in the column.
Yeah. Okay.
Okay.
Thank you.
All right. Other question?
Sir, is this meeting is recorded and you will upload to
Yeah.
Kalam?
Yeah.
Alright.
Let me
Thank
show
you,
you.
sir.
Let me show you. Okay, ni saya tengah record. But I use the
Oh,
third
baik.
party. Okay. Nanti
Can.
I will upload in Kalam, but I need to edit something.
Can, no problem.
Alright.
Thank you, sir.
Alright. Okay, if no question anymore, thank you. And selamat berbuka puasa Kudus Muslims. Right?
Okay, selamat buka
Okay.
tu.
Selamat
Okay.
buka.
Thank you, sir.
Terima
Selamat
kasih, Doktor.
berbuka.